Hi, it's Ryan. Today we're going to give a little historic perspective. And the way we're going to do that is we're going to discuss some different cosmological models starting from nearly 5,000 years ago. So, when we talk about a cosmological model, what we're really discussing is some sort of hypothesis that's trying to describe the universe that we are in. So maybe we could say a cosmological model is a collection of hypotheses that describe our universe. And so that probably wasn't thought of necessarily like this way back when these started being developed. Like I said on one of the first lectures, a lot of the initial astronomy is going to feel more like astrology or even mythology, but we had a lot of learning to do. So we're going back to 2500 BCE, which stands for before Common Era, of course. I think in the late 90s, maybe, I don't know exactly when, but we moved from the AD and BC labels to Common Era CE and before Common Era BCE. And of course, year zero is where it changes from BCE to CE. So it's the same basically, it's just different lettering. What we're going to do is give you a Babylonian cosmology first. Keep in mind these hypotheses, these models of the universe, their purpose is to describe the natural phenomenon that occur all around us. So you might want to, on the side or underneath the notes that we're taking right now, you might want to start a list for each cosmological model that we show you, where you kind of either ask what are or what is this model defining or explaining, and maybe even what is this model missing. So the way that this usually goes is I like to draw out the models and then we can talk through what we're looking at. And I might give you some sort of list, but that's sort of up to you more than anything. No, that's not right. I'm just going to draw it by hand. We'll just do it by hand. There it is. It's a dome, a hemisphere, half of a sphere, and it's a dome that is encapsulating our flat Earth. So I'll never promise to be an excellent artist, but we'll get the idea from these pictures still. So what we're looking at, we have the Earth. It's flat. Keep in mind we're 2500 BCE right now. And the Earth is protected by this dome. It's a I guess not even a glass dome, it's just a protective dome. So we can't really see through the dome. And the dome is, I guess, opaque, so we can't see through it. And the dome is there to protect us small, measly humans from the primordial fires that exist in the universe. And so all around the earth and being stopped by this protective dome created by the gods are the primordial fires. And so I'm just going to quickly add a little flare here. We got God-sized flames that are trying to engulf everything in the universe, but luckily the gods are protecting us from those. These are the primordial fires. We can give it an exclamation point or two. Now, the gods want us to know that they're protecting us from these fires, and so what they very strategically did was they poked holes in this dome, like so. And, you can just kind of put some holes. And so this is an observer, some person standing on Earth, maybe not to scale. And so you might note to yourself that this is the protective dome protecting us from the primordial fires placed there by the gods. And so we would know that they're protecting us. They put little holes, hence we see stars in the night sky. And if you've ever looked at the stars for long enough, you've noticed that the stars twinkle and flash and flicker, oftentimes changing colors before your eyes. And that's sort of what fires do. And so these little holes will change color. They'll flicker with different colors due to these primordial fires. And so this gives us some explanation as to where the stars come from. You could even note to yourself that these stars are the constellation we now call Orion. And over here we have the constellation known as Sagittarius, but a smaller piece of Sagittarius we call the teapot. Whenever you have a smaller piece of a constellation that's well known, or a different grouping of constellations that's well known, we call that group an asterism. And so the teapot is an asterism for the constellation Sagittarius. Anyway, if you were here with me while I was lecturing on this, you might, much like the Babylonian students that would learn this, come up with a few questions as you're watching. Like, it's all fine that we have this dome and that the gods put holes in it to show us they're protecting us from those primordial fires. But what's underneath the flat earth? What is this sitting on? Is it just floating? And if a student in 2500 BCE would ask such a silly question, then the professor would say, oh, I can show you. And the professor would put in his picture these four creatures. And I promise, as I promised before, I'm certainly not the best artist, but I'm doing my best for you. But at each corner of the earth, even though that earth is circular, so it doesn't have corners, underneath, carrying the earth, are elephants. And if you've ever experienced an earthquake, that's because these elephants sometimes take a wrong step or lose their footing a little. And if an elephant in this corner loses its footing, the earth might tilt for a brief second and cause an earthquake. And so, of course, this answers the question as to what Earth is sitting on. But that same student or a different student may then be wondering, what in the world are the elephants standing on? And as the professor or as the Babylonian philosopher, I would say, oh, that's easy. Of course, everyone knows that the elephant is, or all the elephants are sitting on this. Does anyone have any idea what that is? You guessed it, it's a excessively large turtle. And so the elephants are riding on the turtle, and the earth is riding on the elephant, and we are riding on the earth, and the earth is being protected by the dome that the gods placed there to keep the primordial fires from engulfing us. And we came up with stories about where the sun is then. The sun lives inside the dome. Usually we would think about it being carried across the sky by some god. But that student may then be wondering, what is that turtle standing on? Well, it turns out that that turtle is standing on the back of another turtle. And I could do this all day, to be honest. It's turtles on turtles on turtles. In other words, it's turtles all the way down. It's turtles all the way down. Turtles forever. And that is where we would stop that line of questioning, because everybody knows it's turtles all the way down. And these sorts of, I don't know, maybe we could call this a, at this point in this world, we would call this a fantastic or even a fantasy cosmology. This is the thing that is made in science fiction nowadays. But back then, this was a real hypothesis that described many natural phenomena that we would see in the world around us. And these sorts of cosmologies varied from civilization to civilization, but kind of this running theme went on until around 350 BCE. And so that will be our next time. So we're going to move forward almost 1,800 years. And we'll be looking at 350 BCE. And we'll be discussing a very famous Greek philosopher, Aristotle. More importantly, we'll be discussing the Aristotelian cosmology. So I'll say Aristotle's cosmology. It's at this point, or around this point, that we hypothesize that people knew that the earth was round. Okay. So in Aristotle's cosmology, we have primordial fires being kept at bay by this huge dome. It's not really a dome anymore, though. It's a complete sphere. So we're looking in 3 dimensions now at a huge, I guess, black sphere protecting us from the primordial fires. And the gods, for us to understand how divine and helpful they are, placed, of course, these holes to remind us that they're always diligently protecting us from the primordial fires. And so I'm just going to randomly put a few of these constellations like so. Okay, so we're going to go ahead and add in a few more circles, concentric circles, meaning they share the same center. And right in the middle of all of it will be the Earth. So we're going to draw Earth right there in the center. There is Earth, and Earth is rotating on its axis counterclockwise because we think all things in the universe rotate counterclockwise. So I'm going to show that like so, an arrow going around that little axis. Then, of course, orbiting the Earth is our favorite little moon, the moon. And the moon is orbiting the Earth in counterclockwise direction. Now notice in this model, the Earth is spherical and rotating on its axis, which means, of course, that we will see the moon rise and set every day. On the next orbit, we can put the sun. There it is, the sun. They may have called it Sol. And then on that outer orbit, we're going to put a little red planet we like to call Mars. And of course, the sun and Mars are also orbiting the Earth, like so. So if you're creating a list about phenomena that this describes, this technically describes phases of the moon. It describes sunrise and sunset without adding in the need for a god. It describes seasonal constellations. If you notice, much like the previous drawing, we have Orion and we have the teapot. If you were standing on Earth over here and looking up into the sky, it would be daytime, the sun would be out, and so you would not see Orion. So it would probably be a summertime month, and at least in the northern hemisphere. And as we rotate around at night, we would see the teapot. And so it's probably near the fall or winter or even spring, but point is, it describes seasonal constellations. So people may have asked, what in the world are the planets using to go around the Earth? What is holding them in place? And Aristotle said, oh, that's simple. We can see through those spheres that are holding those planets, so they're made of a translucent and very strong material like crystal. And so he said each of these really spherical shells are made of crystal, and we'll call them crystal spheres. We'll call them crystal spheres. And so you have to keep in mind in this picture, it really is three-dimensional. So these spheres are made of a very see-through crystal, and the gods place them there. And if the gods want, they can move them in whatever direction they want. But we definitely have moved away from having turtles all the way down. We have some sort of orbital mechanics beginning. We have a spherical Earth. We have an rotating spherical Earth, so we have day and night and sunrise and sunset explanations. We have the moon and the sun in orientations that describe phases. And so we're really coming along when it comes to trying to figure out these phenomena that we observe in the night sky. We even have one of the planets mentioned, good old Mars. Okay. So this cosmology, or this sort of idea of the universe, stuck around for a few hundred years. It wasn't until 140 CE that we kind of got a new model that was mostly or widely accepted. So I just wanted to discuss phenomenal motion that we noticed. A couple more notes here, and then that'll do it for this video. So as you could see, at this point, 350 BCE, we knew the Earth was spherical, and we knew there were other planets orbiting the Earth. I'd like to note that Aristotle's model is a geocentric model. A geocentric model means that it is Earth-centered. So this was one of our first geocentric models that has some sort of orbital mechanics, only these aren't orbits, they are crystal spheres. They're real physical objects. If you were to be able to jump or somehow have a rocket ship and move off of the planet, you would crash into that crystal sphere. But that wasn't much of a possibility way back then anyway. In fact, I think if you were to suggest something like that, you would probably be thought of as a heretic. Another little interesting note is that the word planet comes from the Greek word planetos. And this Greek word planetos means wanderer. Wanderer. And so that's how we first discovered these planets in any way at all, is the fact that we had all these constellations, all these holes poked in by the gods that remained where they were poked permanently. We would always see Orion every winter, and we would always see the teapot every summer, and we would always know and predict when we would see them, and they would always be there, because those were permanent holes in a permanent structure that protected us from those very real primordial fires. It just so happened, over thousands of years of watching the sky, we became very familiar with these wandering stars that would not appear in the same spot every season, no matter what. Mars, a red wandering star, would slowly but surely make its way through the night sky from west to east over the course of years. We thought it must be the gods moving these stars, but that's why we had to put the Wanderer on its own orbital plane. I'm assuming at this point they probably were very aware also of Jupiter and Venus and even Saturn. So we were aware of these wandering stars. And the way I want to talk about the way these wandering stars would move through the night sky, I'm going to just draw you a quick little picture of a well-known constellation called Orion. This is technically a blurb, I guess. This is a blurb in the notes. So what I'm going to do is draw Orion the Hunter. I'm going to try to be at least somewhat accurate with the colors and the placement of the stars, but I'm sure if you were to take a picture of this and compare it to like a stellarium image of Orion, you'd be like, oh, that's way off. But, anyway, this little nebula that hangs off of Orion's belt is known as M42, Orion Nebula. Orion's belt is technically an asterism because we identify it separately in a sense. We call it Orion's belt. So that word I keep using is asterism. An asterism is a well-known piece or combination of different constellations. So I'll leave constellations in. A well-known piece of a constellation. Orion's belt is an example of an asterism. So there's just a technical thing here. Technically, constellations are now defined as the entire area around them. So we define constellations, which I think there are 88 defined constellations, as the area around the constellation. So I'm just guessing it. So technically, Orion is defined by the entire area of the sky like that. And even the 8 to 10 stars that we see and define as Orion are technically an asterism. I usually don't talk about it like that because I think it's confusing, and I just like to keep our constellations the way you kind of think of them. But if you're researching other things online, you might hear that, and I just want you to know that it's not wrong, it's just kind of confusing. Anyway, we have this top left star is Betelgeuse, my bad. A lot of people call it Betelgeuse or Betelgeuse or Betelgeuse. It is, I think, technically Betelgeuse, but I don't have a good Arabic accent. This is Bellatrix. This is Rigel, Safe. And then again, these middle, the Orion's belt is Elnatak, Elnalam, and Mintaka. I'm going to erase those. I just wanted you to see. So here's the reason I'm drawing this out. I want to show you the motion we would observe with Mars normally. So normally, over the course of months in the year, we might see Mars here, and it will slowly but surely make its way across the sky from from west to east. So it will slowly, over the course of months, wander through Orion, hence the name Wanderer. We call that prograde motion. West to east motion over long periods of time is called prograde. What we would observe is that Mars or other planets would be moving like they normally do, but then over a 3-month period, it might slow down and stop, and then start to go the other way, and then continue forward. Anytime we have east to west motion over long periods of time, it is called retrograde motion. And the next video will discuss retrograde motion in more detail. So that'll do it for this video. Thanks for watching.